Okay, so I'm going to be taking you guys through Trench 10.3 Problem 7. This is talking about fundamental sets of solutions and how to verify each different answer that's given, and plugging in values to find an initial value problem and finding a formula to actually use for any kind of initial value. So for problem 7a, asks you to verify both y1 and y2 as fundamental sets because they're given here. We don't have any proof. So to do that, you see that there's this initial equation here. We have a, we have each y1 and y2, so we just have to find the derivatives of each. And after plugging them in, you can easily see how to solve this afterwards. So we know that to solve this multiplication step here, you have to distribute this part into this whole column, and then this part into this whole column. And then we have this solution here on the top row, this solution on the bottom row for y1. So we know that both of these are going to be solutions. So that takes care of step A. So in order to find part B, we have to set up a general solution for our equation. So we know that y1 equals this, y2 equals this, and in all other ways that we have solve for our linear differential equations, we know that we can add these together. In order to do that, we just put in C1. You can put it in the matrix form, or you can put it as they have it up here. Either way, it'll come out to the same thing, plus C2, and that's going to be 1, negative 1, e to the negative 2t. Now, to start solving part B of this equation, we know that in all other linear differential equations that we've solved for, we have to equate y1 with a c1 constant that's completely arbitrary, and the same thing for y2, but call it c2, and then we can add them together and call it the general solution. So that's what I've done here, and I'm how it is in matrix form, and we know using the solution up here that y prime is going to equal the A matrix times y, and that's what that will look like. And we know from the same process that I used up here that in order to solve for this and make it into an equation that we can easily understand, so that's what this final matrix is going to look like. And let me just add them together for you. Now once we get this matrix right here, you can either solve it one of two different ways, and what I'm going to be showing you guys is how to do it through the calculator today. But first I'm going to take you through the long way because we're going to need to use that long way step for part C anyways. So that's what this matrix comes out to equal. I'll be showing you guys two different ways on how to solve for this from this point on. I'm going to take you through the long way first, and then I'll show you a way through the calculator. So solving for that first line, we have this equation here, and this is going to be equal to where t equals 0. And I just used a little quick matrix so that we can clarify what k1 is going to be equaling. Obviously it's going to be equal to negative 3 and 9 for this initial value. We know that 6c1 e to the 0 is going to equal 1, so it's just going to be 6c1 plus 6c2 equals negative 3. Now if we solve for our second equation, it's going to come out to be 6c1 e to the 6t minus 6c2 e to the negative 2t is going to be equal to k2. 2 is going to equal negative 1. And we can go ahead and use this to solve for C1, positive 1/2. So then we come out to have a matrix that's 1/2 over 1. Now, in order to solve this through a calculator, there's a really easy way to do that, and I'll show you that in just a second. So before we did this long step, we had determined that y prime is going to be equal to this. We know that we can reduce this down to this matrix down here if we just look at the coefficients. So looking at your calculator, put a second in matrix, which is right on the x to the negative 1, you can see it, they give you A, B, C, D, and all through the alphabet. If you go over to edit, click A1, you do a 2 by 2 matrix, because that's what we have here in your values, using matrix B to find our k values, which we know are negative 3 and 9. This is going to be a 2 by 1. 2 meaning the columns, 1 being the rows. So then we can do negative 3 and 9. And the way that you can solve for this to easily find the values of what's going to be C1 and C2. Back to second matrix, you can see the names, you put in A, and that just gives it to that. Then you have negative 1, and then you multiply it by the b value. If you press enter, that'll give you exactly what we found before, which is just c1 and c2 equaling 1/2 and -1. And if you flip it over, that is exactly what we found right here. It saves a lot of paper to be able to use your calculator instead. However, we will need the long way to be able to solve for part C in this part. I just thought this was a useful way to verify your own handiwork as well. So now that we can confirm this is what our C1 and our C2 equal, so we know that originally we had this. So if we put in our C1 and our C2 values now, and that corresponds with what's in the back of the book at Trench. So we know that for question C, it asked us to use the last answer to find a formula with any kind of arbitrary k. Even though these have values, we're going to be using the k1 and k2 notation like I used down here. That just makes it a little clearer to be able to understand what process we're actually doing. So if we had c1 equal to -k1 minus 6c2 over 6, that's going to reduce down to -1, or we'll just keep k1 over 6 minus c2. So we find that c2 is equal to -k2 over 12 minus k1 over 12, and if we plug in this value into this equation back up here, it's going to be equal to c1. So distributing that back into the original equation, we'll be able to find for the solution. So we have k2 minus k1 and on both the c1s. And here I've been able to pull out a 1 over 12. It just makes the writing a lot simpler and easier to understand, and that's the final answer.